You use Git every single day. Commit, push, pull. It works until it doesn't. And then it's 11 p.m. and you're frantically Googling how to undo Git rebase, mass copying commands from Stack Overflow, praying you don't make it worse. Here's the uncomfortable truth. Most experienced developers don't actually understand Git. They've memorized the commands. They have no idea what's happening underneath. In the next few minutes, you're going to see that everything Git does, every command, every diagram, every panic at 11 p.m. comes down to two things: snapshots and pointers. Once you see it, you can't unsee it. Let's start from zero. Forget everything you think you know. Git is a database, and the fundamental unit of that database is the commit. So what is a commit, actually? It's a snapshot, a complete photograph of your entire project frozen at one moment in time. Not the changes you made, the entire state of every file exactly as it existed. Each commit contains three things. 1, a pointer to that snapshot. 2, metadata, who made it, when, and the commit message. 3, a pointer to the parent commit, the commit that came directly before. When you make a new commit, Git saves the full state of your project and links it back to where you were. This creates a chain. Each commit points to its parent. Parents point to their parents, all the way back to the very first commit. And that first commit is special. It has no parent. It's the origin point of your project's entire history. Later, when you merge branches, you'll create commits with two parents, but we'll get there. For now, remember one thing. Commits point backwards. Always backwards. Children know their parents, but parents never know their future children. If everyone just committed one after another, you'd have a straight line. But real development is messier. You branch off for a feature, a colleague branches off for a bug fix. Now you have commits sharing the same parent, but going in different directions. Then you merge, and you've got a commit with two parents. This structure has a name, a DAG, a directed acyclic graph. Sounds intimidating. It isn't. Think of it as a family tree. Directed means relationships only go one way. Children point to parents, never the reverse. Acyclic means no loops. Nobody can be their own grandparent. Graph just means nodes connected by lines, commits and the links between them. That's the first half of Git. Snapshots chained together. Now here's what most explanations miss. There's a second half. Every remaining piece of Git you're about to see is just pointers moving around this graph. Once you see that, every command starts to make sense. Meet our first pointer. Branches. When people first learn Git, they picture a branch as this heavy, complicated thing, a whole separate copy of the codebase. Completely wrong. A branch is just a sticky note, a tiny text file containing exactly one piece of information, the hash of a commit. That's it. When you create a new branch called feature-login, Git creates a small file that says this branch points to commit A1B23. Nothing more. Look at any Git graph. Those branches are just labels stuck onto different commits. Branches don't contain commits. They never have. When you make a new commit while on a branch, Git creates the new commit pointing back to where you were, and then moves the sticky note forward to the new commit. That's branching, the entire concept. This is why creating a branch is instant. You're not copying anything, you're placing a sticky note. And main, not special, just another sticky note we've agreed is the primary line of work. So we have commits and we have branches pointing at commits. But how does Git know where you are, what you're actually working on? Meet head. And here's the surprise most Git tutorials never mention. Head usually doesn't point to a commit, it points to another pointer. When you're on the main branch, head points to main. Main points to a commit. 2 hops to figure out where you are. Run git checkout feature, and head moves to point at the feature branch instead. You're now working on that branch. But here's the situation that confuses people. What if you check out a specific commit, not a branch, a raw commit hash? Now head points directly to that commit, with no branch in between. Git calls this detached head state. Sounds scary. It isn't if you know what's happening. You can still work, you can still commit, but no branch is following along. When you switch away, those commits become what Git calls orphaned. No branch points to them anymore. They're floating in space, and eventually Git's garbage collector will clean them up. Remember that word, orphaned. It's going to come back. You've probably seen this play out. A developer checks out an old commit to test something. While they're there, they find a bug. They fix it, they commit the fix. Then they run git checkout main to go merge their fix, and it's gone. Vanished. It was never on a branch. They can't find it anywhere. Orphaned, then garbage collected. 2 hours of work, gone. This is why Git warns you about detached head. Not because you're broken, because anything you commit won't be saved unless you create a branch to hold it. Before we can talk about undoing things, we need one more concept, the one that confuses almost everyone. Git actually has 3 places where your code lives. 1, your working directory, the actual files on disk, what you see in your editor. 2, the staging area, also known as the index, a waiting room where you prepare what will go into your next commit. 3, the repository, the database of commits, the permanent history. Edit a file and it changes in your working directory. Git notices but doesn't care yet. Run git add and you're moving those changes into staging. I want this in my next commit. Run git commit and Git writes everything in staging into permanent history. Why does this matter? Because the commands we're about to discuss manipulate these 3 layers in completely different ways. 3 commands. They all look like they undo things. They do completely different operations, and confusing them can cost you real work. Let's go one by one. Checkout moves head. That's its job. Git checkout main. Head points at main. Git checkout C1. Head points directly at that commit, and your working directory updates to match its snapshot. But, and this is important, no commits change. No branches move. History is untouched. You're just looking around. Safe, non-destructive, purely a shift in your viewpoint. Now something more dangerous. Reset moves a branch pointer. When you're on main and you run git reset C1, you're telling Git move main to point at this commit. The commits that were ahead still exist in the database, but they're orphaned. Same pattern we saw with detached head. No branch points to them anymore. And here's where reset gets nuanced. It has 3 modes, and each one hits the 3 areas differently. Soft reset moves the branch. Staging unchanged. Working directory unchanged. Your undone changes appear staged and ready to commit again. Use it when you made 3 commits but want to squash them into 1. Mixed reset, the default, moves the branch and resets staging to match the target commit. Your changes still exist in your files, just unstaged. Use it when you committed something but want to restage it differently. Hard reset moves the branch, resets staging, and resets your working directory. Your files change. Uncommitted work vanishes from your disk. I have watched developers lose days of work running git reset --hard thinking they could just undo it. You can't, not easily. The orphaned commits are recoverable if you know Git's secrets. But your uncommitted changes, the stuff you never committed at all, gone forever. Use it when you want to abandon work and start fresh, and you're absolutely sure. Revert takes a completely different philosophy. It doesn't move anything, it doesn't abandon anything. Revert creates a new commit that does the opposite of an old one. Commit C added 50 lines. Git revert C creates commit D that removes those same 50 lines. History is preserved. The original commit still exists. You've just added a new one that says, we decided to undo what we did earlier. Use it when you need to undo something that's already been pushed and shared. You can't rewrite shared history, but you can add to it. Quick summary. Checkout only moves head, safe for exploring history. Reset moves a branch and possibly your working directory, risky for reshaping local work. Revert moves nothing and creates a new commit, safe for undoing shared history. Finally, the command that terrifies most junior developers. Rebase. Set the scene. You created a feature branch off main. You've made commits B and C. Meanwhile, main has moved forward with X and Y. You have 2 ways to integrate. Option 1, merge. Create a merge commit with 2 parents. History shows the truth. 2 parallel lines of work joining together. Option 2, rebase. Take your commits and replay them on top of the new main. But here's what you have to understand. A commit's identity is its hash. That hash is generated from the content, the metadata, and the parent pointer. Change any of those, including the parent, and you get a completely different hash, a different commit. Which means Git can't move commits. That's not a thing that exists. Rebase can't actually rebase. So what it does is look at commit B, calculate the changes it introduced, create a new commit B1 with those same changes but with Y as its parent. Look at commit C, do the same, create C1 sitting on top of B1. Move your feature branch pointer to C1. The old B and C? Orphaned. Same pattern, third time now. Garbage collection will eventually clean them up. That's what rebasing actually does. And that is exactly why you never rebase commits that others have already seen. If your colleague has the old commits and you push new ones with the same content but different hashes, Git sees them as completely unrelated work. Merging becomes a nightmare. Duplicate changes appear. Conflicts explode. But on local branches you haven't shared, rebase is powerful. It keeps history linear and clean. Just know the trade-off. You're choosing a clean story over the messy truth. Here's the thing nobody tells you until you've panicked at least once. You've made a mistake. You reset hard. You rebased wrong. Commits are gone. Run git reflog. The reflog shows everywhere head has pointed recently. Every checkout, every commit, every reset. Those orphaned commits from your reset, those old orphaned commits from your rebase, probably still there. Find the hash, create a branch pointing to it, and you've recovered your work. Git almost never truly deletes anything immediately. It just hides things. The reflog is your map. One caveat, reflog entries expire, usually 90 days for reachable commits, 30 days for unreachable ones, so don't wait months. But if disaster struck 5 minutes ago, you're fine. Let's step back. Every single thing Git does is one of two operations. Commit creates a snapshot, branch, head, checkout, reset, rebase, reflog. Every single one of them moves a pointer, or remembers where a pointer used to be. That's the whole thing. 7 commands, 2 operations, 1 mental model. Next time it's 11 p.m. and Git breaks, you won't be copy-pasting Stack Overflow commands and praying. You'll ask one question. Is this a snapshot problem or a pointer problem? And from there, you'll know exactly what happened and exactly how to fix it. If this helped, hit like and share it. Thanks for watching. See you in the next one.